Hello, hello. This video will be going over our Unit 4 quiz. This quiz goes over solving for equations and solving systems of equations. So without further ado, let's go ahead and jump into problem number 1. The instructions say, find the solution for the following equations. So I'm supposed to solve both of these equations, which means I have an x value here, I have an x value here. In both these equations, I'm solving for x, meaning my answer is going to look like x is equal to some value, which means I want to get x by itself, which means I need to cancel everything around x. So you'll notice that there are quite a few operations that are happening to x. So that the way that we start our work, the way that we organize ourselves, is by making an operations table and an inverse operations table. The operation side, what we're trying to list out is what happened to X and in what order did happen to X. We're trying to figure out step one, what happened to X, then what happened, and continue going until we list out all the things that happened to X. From there, we find out their inverses so we know how to cancel all my operations so that I get X by itself. So let's go ahead and take a look. I've identified my X value here. And now I need to figure out what happened to X first. And you'll notice immediately next to my X is R5. A number next to a variable is multiplication. So we're going to say that we multiplied by 5 to my X value first. Next, I notice that my 5x or my X is under my square root. And I can't deal with anything outside of my square root until I account for everything on the inside first. So what we write is times 5. I got my 5x, and then the next thing that happened is my plus 1. So my next operation would be plus 1. Then, as I just said, I can't get out of my square root until I deal with my square root. So before I address my 4, I must say that what happened to x next is I put it under a square root. So far I've dealt with my 5, my 1, my square root. Checking off as you go is a good strategy of making sure you didn't miss anything. And then finally, I have my plus 4 at the end, plus 4. And this is not arbitrary. I'm not just saying, oh, these are things that happen. I'm saying this happened first, second, third, and fourth. The order is going to matter because we need to cancel in an order that reflects what happened here. The biggest problem that I saw when I was grading the quiz was people starting this problem and saying, "Oh, I have a square root. I'm just going to square both sides because that's how I know how to cancel it." And that is not the case. You do not, you can't just cancel in any order you want. You must be following your inverse operation table. Figure out our operations, and we need to cancel in that same, well, rather than same order, it's actually the opposite order. Let's go ahead and get our inverse operations out first, and then we'll talk about the cancel order. So the opposite of plus 4 is minus 4. The inverse operation of taking a square root is taking something to the power of 2. The opposite of plus 1 is minus 1. And the opposite of times 5 is divide by 5. And when we think inverse, I want to think opposite. I'm going the opposite order. So my first inverse operation I'm going to do to solve for x is actually minus 4. I'm working from the bottom down, so I could cancel in order. So that's going to be step 2, step 3, and step 4. Okay, so I have my outline of what I'm going to do. Now let's go ahead and see what it looks like when I actually do it. So I have minus 4 and minus 4 because what I do to one side, I must do to the other. And this cancels, and I get 10 minus 4 is equal to 6. And of course, what's left over on this side is 5x plus 1 equal to 6. So I look at my step number 1, and I am done. I check that off. My second inverse operation, the opposite of a square root, is taking something to the power of 2. When I do to one side, I must do to the other. So you might look at this and say, oh, this looks complicated. I'm not sure how to start this. It looks crazy. And you're a little bit right. If you were doing this operation and actually multiplying this out, there might be quite a few steps in here. But we are not doing any calculations on our left-hand side. Our goal on this side is to get my x by itself. And the reason we introduce the square, the power of 2, is to cancel. My goal here is to cancel. So if you guys are changing, adding, any other elements to the side, we're doing something wrong. All that we're trying to do is cancel. So with my square root and power 2 canceled, I get 5x plus 1 is equal to 36. 6 squared is going to be 36. I then minus 1. I get 5x is equal to 35. And of course, I divide out my 5. That becomes x is equal to 35 divided by 5 is 7. So my final answer is x is equal to 7. All right, if we're comfortable with that, then let's go ahead and take a look at number 2. Number 2, this one we're going to start a little bit differently because although you could start by making your inverse chart, I notice right away that I have fractions. Whenever you start with fractions, you want to take note of that because generally speaking, you want to cancel all your fractions as early as possible so you don't need to deal with them in the middle. They just make your calculations harder. You need to remember all your fraction rules and their interactions, which if you can do that, power to you. You don't need to worry about this step. But I would highly, highly recommend that the first thing we do is cancel out our fractions. Now, fractions are the same thing as saying division. This problem is saying x, absolute value of x minus 4 divided by 6, and 1 divided by 2. So because fractions mean division, in order to cancel them, we need to multiply. And we need to find the right number to multiply by. In this case, I'm going to multiply with 6 because 6 cancels with 6 and 6 cancels with 2. So it's going to cancel out all my denominators. But of course, what I do to one side, I must do to the other. So we're going to write this out as 6, absolute value of x minus 4, all over 6, plus 6 over 2 is equal to, and I'll just multiply that out, that'll be 18. Remember, I'm multiplying not just my fractions by multiplying to the entire side. So I'm multiplying my 6 in, and then I cancel. 6 divided by 6, of course, cancels. And then left with absolute value of x minus 4. 6 divided by 2 is going to be 3, is equal to 18. And at this point, I could start making my operation chart. And now I could see what happens to x is I minus 4. I apply my absolute value, and then I add 3. So the way that I canceled this is by minusing 3. And as far as dealing with my absolute value, if you recall, we said that there is no inverse operation for absolute value. However, we do know how to deal with it. We do know how to resolve it. And that is by splitting our solution into a positive value and a negative value. And of course, opposite of minus 4 is plus 4. So let's see what that looks like. So we minus 3, and I get absolute value of x minus 4 is equal to 15. From here, I need to split my equation. Let's go ahead and section this off so I don't mess up my work, confuse it with anything else. I need to split this. So I'm going to write x minus 4 and x minus 4. Whatever's inside my absolute value does not change. What changes is my solution. So I need to test for when my solution is positive, 15, and when my solution is negative, negative 15. I still have to solve for x, so I have to plus 4, get x is equal to 19, and I have to plus 4, and negative 15 plus 4, x is equal to negative 11. And we have our two solutions for problem number 2. Now moving on to number 3, this is our only uh, definition or strategy problem. And the question's asking us, how can you find the solution to a system of equations? We've been saying it so much in class. I'm hoping this is not a surprise. But in order to find the solution to system equations, I must set my equations equal to one another. That is our first step. That is how I find the solutions graphically. That's where the solution happens. This is what we're looking for. There are a couple of variations that I saw, but this is essentially what we're looking for. This is how we set up uh, our work in order to solve a system of equations. Speaking of, here we have some systems of equations. Let's go ahead and take a look at number 4. So, as I said before, in order to solve a system of equations being just working with more than one equation at a time, in this case, I'm working with two. In order to solve a system, I need to make sure both my equations are equal. And that happens by literally just writing 3x minus 2 plus 1 is equal to x plus 2. I'm literally setting one equation equal to the other, and now I solve. If you just put this on the test, this is half the credit for the problem, and the rest of the credit is just solving it out. But if you ever get stuck, please at least give me this first step so we're at least aware of the setup. But I hopefully we also have enough practice that we're actually able to move forward with this problem. All I'm doing is emphasizing that this is very important for us to keep in mind because that's the only way to set up this problem in order to help us solve. That being said, I am solving these systems, which means I'm trying to get x by itself. So a very similar answer that I'm seeking as before, but now I have a couple more difficulties. My main problem is that I don't have just one x anymore. I have two x's. I cannot solve for x while I have multiple x's in my equation. So your first goal should be to either combine or cancel all your x's until you just have one left. So let's see about doing that. So I can't interact with this x because it's inside the parentheses. So in order for me to move forward with this, I need to free this x. And the only way to deal with these parentheses is by dealing with this 3 on the outside. So this 3 is being multiplied by this parentheses. So I'm going to go ahead and distribute my 3 into everything on the inside. We're going to call that 3x minus 6 plus 1 is equal to x plus 2. Now I have all my x's are free. There are no groups, there are no parentheses, there are no square roots or absolute values. All my x's are free to move around and interact with one another. Let's clean this up real quick. 3x negative 6 plus 1 is going to be negative 5 is equal to x plus 2. And now we see that we have our x components and we have our number components. Let's go about seeing if we can combine our x's. So I have an x on this side. I don't want an x on this side. So I'm going to go ahead and cancel by subtracting x. X minus x cancels. But through the process of canceling, I'm actually also moving my x over. So I have 3x minus x, giving me 2x minus 5 is equal to 2. From here, now I just have one x all by itself, and I could go about trying to isolate that x. So I'm going to plus 5 and plus 5. That's going to be 2x is equal to 7. I want to get rid of my 2, so I divide by 2, and x is going to be equal to 7 over 2. Got a fraction on this one. I know not all of us love fractions, but they come up when we need to get comfortable with them. If you ever get a weird looking answer, go back, definitely check your work. But sometimes we just get a fraction. This one's going to be 7 over 2. And finally, we're going to take a look at number 5. We have another system, and our setup is similar. I have 3, 2x minus 1 plus, ooh, that doesn't look great. Let's clean that up. Minus 1 plus 2 is equal to 3x over 2 plus 5. Now, you'll notice two things. One, I have a fraction. I definitely want to get rid of this fraction. but you'll notice that I also have my x inside of parentheses here. I'm actually going to go about solving my parentheses first, distributing and getting rid of my parentheses first, because I'm trying to lessen the components I'm going to multiply when I multiply out this fraction. So I'm going to make this 6x minus 3 plus 2 is equal to 3x over 2 plus 5. And I'm going to have 6x negative 3 plus 2 is negative 1 is equal to 3x over 2 plus 5. So I'm breaking my rule a little bit from number 2. I'm not dealing with my fraction first. However, you'll notice all the steps that I took did not affect my fraction at all. So I'm still avoiding working with my fraction, but now at this point, I can't really do anything else until I deal with that fraction. So I'm going to go ahead and say, see, I only have one fraction. I only have one denominator. So I'm just going to multiply by 2. Multiplying by 2 will cancel with my 2. And the reason I'm doing it to everything in the equation is because whatever I multiply, I can't just target the fraction. I have to do it to the whole side. And of course, what I do to one side, I must do to the other. So let's go ahead and resolve this. 2 times everything in here is going to be 12x minus 1 is equal to, when I distribute this 2, this times 2 cancels with my divide by 2. So I'm just left with 3x. And then, of course, 2 times 5 is going to be plus 10. So now my fractions are gone, and now I want to combine my x's. So let me cancel this x on this side. Minus 3x. I get 9x minus 1 is equal to 10. And I'm going to get plus 1 plus 1. Hold on, something's gone wrong here. What went wrong? Oh, hopefully some of us caught on to that. But this is wrong right here. It shouldn't be minus 1. When I distribute my 2, it's 2 times negative 1. It should have been a negative 2. So apologies for that if you have to go back in your notes and double check. But it's also a good example of what it looks like to see and sense that something's wrong and going back to check your work. So that should have been minus 2, which means in order to cancel my minus 2, I'm going to go ahead and plus 2 here. So the mistake was that I should have multiplied by my 2 and negative 1 here, and I didn't. I rectified that, making this a negative 2. And when I do that, I'm going to get 9x is equal to 12. If I divide this out, I get x is equal to 12 over 9, or 4 over 3, or 1.3 repeating. If you simplified or threw into a calculator, that's fine, but these are our answers. Okay, hopefully this quiz review helped you. Happy studying, and if you have any questions, please feel free to email me or reach out in some other way. Thank you for your time. Happy studying.